2 and 4, answer can be 2 or 6. I don't know. If 3 and 7 is given, I guess answer is 6. 7, 9 is given, answer is 8. 0 and 4 is given, answer is 2. 3 and suppose 0 and 5 is given, answer is 2. Right? Correct, I guess. This is what it is trying to say, I believe. So input is given here, 2, 6, left child, right child, then its left child, and then its right child, then this guy's left child, and this guy's right child, then this guy's left child and right child, then this guy's left child and right child. Yeah. So P equals 2, Q equals 8 means the LCM of 2 and 8. So 2 and 8, it is going to be 6. That is saying like most immediate descendant of both two nodes, right? But immediate it is saying, right? Lowest common ancestor defined by the lowest T as the descendants. Alright. P equals 2, Q equals 4 means 2 and 4. So 2 and 4, answer can be 2 or 6. Answer is 2. Okay. Lowest node T that has both P and Q as descendants. Okay. I guess they should be on same level or what? Whatever. Okay. 2. Since a node can be descendant of itself according to LC definition, that is why 2. Otherwise, the answer could have been 6. Alright. Now this is also this is a BST. Fine. This gives a clue, maybe some kind of clue. And I didn't expect a medium level question, to be honest. Alright, let me check if the audio is recording. Yeah, audio is working. How I'm gonna solve this? This is a little confusing. Given this can be a question like given 4 and 7, right? What could be the number which is between them? Between them, not greater than greater than 7 or less than 4, right? Between them is 6. So what is the number that is between 3 and 7? That can be 4, 2 and 6. Alright. So 4, 2 and 6, but the correct answer is going to be 6, right? So how we are going to answer this one? 6 6 to 8. Let me check this on Wikipedia then. Least common ancestor of two nodes. Two nodes in a tree or a DAG. V and descendants. CA of V and W is T. In T is shared ancestor of V and W that is located farthest from the root. Okay. Notation of may be useful instance as produce of determining the distance between pair of node in a tree. The distance from V to W can be computed as the distance from root to V plus distance from root to W minus twice the distance from root to their lowest common ancestor. For X and Y it is dark green, right? Other common ancestors are shown in green light, but the lowest common is in dark green. Yeah, correct. Alright. Okay, we have P, we have Q. So we can traverse a tree from root only, right? That is already understandable. Like we are given root, we are given two nodes P and Q as well. So I'll start iterating from root from given example. Suppose 2 and 8 is given. I'll start iterating from root if 6 is parent of 2 and 6 is parent of 8. That means 6 is the answer. No, I guess. Let's suppose 0 and 7 was given, right? So, how will you find that answer? Uh, I'll start from 6. I'll check if the value of 6 is like I'm starting from the top. That is fine. That is understandable. And if the value of 6, right? If the value of the root node is less than the given left side node, what you say, 0, like sorry, greater than 0 but less than the given node, then we can say that is the LCA. Yeah, right. If the current node has value which is smaller than its left node and greater than its right node, sorry, like greater than its left node and smaller than its right node, then we can directly say it is the LCA, right? Otherwise, what we will do, we will either go left or right. What you say? We can exactly do like it is a binary search, no? If it is less than, we have 0 and 7, right? And let me make a tree. How can I visualize a tree? So yeah, let's visualize it here. So how to visualize it? What the fuck is this? Let's see, whatever, maybe it is understandable there. Let me zoom out then. Zoom out. Yeah, it is looking better now. Yeah, better. It's looking better, I hope. You're able to see it. I'm not able to zoom in. Okay, so 6 to what I'm trying to say here is suppose we are starting from 2 but the answer is 3 and 5. The Q and P, let's do it in the let's do it in the question itself. Wait. The given is 3 and 5, right? P and Q, and we are starting from 6. We see 6 is like 6 is obviously greater than 3. That is fine, but it should not be greater than 5, right? That is what we understand. Like if it is not greater than 5, I mean it is greater than 5, it should be like, it should not be greater than 5, it should be smaller than 5, then only we can say yeah, it is this is deserving to be a LCA. Now it is not. So what we will do, because it is greater than the right side value, then we will traverse to left. Again, we'll see 2 is here and 2 is definitely less than 3, right? And it should not be less than 3. That's the one thing which we need to understand. Like given a node, its left side value should not be higher than him, right? So if so, we are saying, let me write it down. What I'm saying is left side should be left child, means left side should be, that is P should be left side should be less, that is P from the given node. Right side should be more, that is Q from the given node. Then what we should do, if the left side should be less, right? Let's see, let's start with 6. Left side is less, that is correct, so we are fine with that. But we will check the right side. Right side is small and we are saying more, else go to left child, yeah, and else go to right child and repeat. So yeah, we can do this, I believe. And number of nodes in tree in the range of this. All nodes value are unique. P is not equal to key. P and Q will exist in BST. These are the guarantees we are getting. And for 2 and 4, left side should be less than and equal to. Well, I guess less than and equal to should be there, then only we will be able to return 2 as answer, right? Otherwise we won't. So we can say a descendant of itself. So let me write it in an iterative way. If not an iterative way, let me write it in a recursive way. If lowest common ancestor, I mean, first we need to check, then only we can call it, right? If root is less than or equal to root dash val is less than or equal to its left side, that is P, right? I mean, if it is equals, I mean, what can I say? This is a little bit confusing. Let me do normal condition which I have written above. If root's value, right? If the left side should be less, that is from the given node, and left side should be less. In what case I will be, what I'm trying to say, in what case I will be accepting the solution, that I need to represent here first. So that will be the base case, right? If root value is, so root value is less than Q value and less than equals to, I mean, okay, less than equals to, and root value, I need to put some spaces in between so it would look a little bit understandable. If root value is greater than equal to P, then we can say then we can return, I mean return root. I guess that should be the answer. And next we should be following through it as a binary tree now. we should be doing like checks, right? Which I have said, if root dash val, and one of this will be true at a given time, right? If root dash val is greater than left side, that is q, I mean that is p. So it is if it is less than left side, then in that case, if it is less than that side, that means if it is less than p, then we should do this ancestor root, we should go to right. I mean, what if there's no right? This should be, because they couldn't, they wouldn't have given this node itself. Na? That node probably is down there somewhere, right? Let me just work on this assumption. Later we'll figure this out. So root dash right, then we will give p, then we will give q. PQ are not going anywhere, right? So yeah. Similarly, I'll copy this, I'll paste it, and left, and I need to do Q here and reverse this sign. Let me check if this works. Otherwise, I'll what is this? Comparison between pointer and integer. Okay, I need to put as a val. Val, obviously, here as well. Val, here as well. Val. Now let's do this. Why it is happening to me? X brackets are only okay. I need to return as well, right? Return root. Let's do return root. Let's see. Runtime error, member access within null pointer, type renode, undefined behavior sanitizer. Yeah, obviously we do not have Q, and P and Q is there, right? So P and Q are given, obviously. Then we have given the root as well, obviously, and then we're returning the root, right? What is wrong with this? Root is given, that is fine. Then Q itself is root, I believe, in this case, and I mean P, and Q is what it is. So Q Q1, P equals 2, Q equals 1, P equals 2. What I'm doing wrong here? I'm actually very sleepy right now. What I'm doing wrong? Let me understand. guess I won't get this much time in an interview. Why my brain is not working. Root value is less than equals to Q value. Like I'm assuming like P and Q can be any random nodes then in that case. But I'm trying to access root value only, right? So this one, this one test case, this one, again remove this one. Let's try for these two. So at least not a runtime error. I can at least do something about it. Answer is 6 and we are getting 6. That's fine. Right now P is 2 and Q is 4, but answer I'm still getting a 6. So I need to understand where I'm getting this wrong. So what I say here is, to get answer as 6, I'm starting with 6 itself. So root is given as 6, right? And it is fulfilling both of them. Like 6 is 6 is smaller than, like greater than 2, right? So 6 is greater than 2. Is 2, which is I'm hoping as the left one, but that is not the case. Okay, so P is 2 and Q is 4. So if P value is, root value is greater than P value and root value is less than Q value, that is 4, then only you can return root. Otherwise what you do is you call the function again. I guess return statements are missing, so answer is getting missed. Return turn and return. Let me check now. The answer was not getting propagated properly because see, that is what I need to analyze in the list. So one more thing to analyze. So I need to add another case which I removed from here. Test cases, test case, add this one. So I'm little skeptical about the other way around. So I don't know, like this can be any pair, like node pair. You're getting the point. Like if we switch P and Q value, let me just do it first. 2 1, P is 2, Q is 1. Let's do this. Yeah, Control C, Control V. P is 2, Q is 1. Let's run this, and yeah, we are getting this null point exception for this one from this itself. I'm not getting, like, what's the problem here? P and Q is obviously given as 2 and 1. So this is coming as a null point exception. Test case, if I put it as 0, then let's try. We are looking at 2 and 1, so answer should be 1. Six, 0, 2, 4, 7, 8. Let's do 8 and 7. 8 and 7. I hope I get the same error lines. I guess right now I'm battling with some edge cases. I believe the question is done. For 8 and 7 we are getting this. But if we try 7 and 4, I don't think we will get this. 4 and 7. 4 and 7. Let's do this. See, you'll get answer 6. If I try to modify it further, if I give 2 and 4, 2 and 4, 2 and 4. Let's run this. Still get the answer, right? And if I do it as 4 and 2, I'll not be getting an answer, I believe. Let's see. I'm getting the point now, maybe. Let's do 1 and 2. Let's run it. Yeah, so this can be a problem because let's suppose I'm just swiping these values in this place. Let's suppose this is 4 and this is 2. Let's run it. Okay, so here the problem is I'm thinking as P can't be greater than Q, because I'm thinking it like this, right? So it is just saying like P and Q can be a pair, right? So we need to get the value, which one is greater, which one is smaller. As per that we need to arrange these. So like 6 is here, and we can say 8, then we can say 3 can be not possible. It has to be greater than 6, right? So say it is 7. So in this case, when 1 and 2 is there, right? So let's do this test case. And this case, 2 is the root, so less overall is in left. So this is a fine case, and we have to assume, given the scenario, Q is now the right root, Q is the left root, and 1 is the right one. P is the right one. Suppose in this case, as we have replaced, right, we are making P as 4. That means P is the left one and Q is 2. Q is the right one. Suppose we are doing 4 and 7, right? So 4 and 7. Let's do it. I think this will get solved. And we'll have to remove the third case. Let's run this. Yeah, this got solved. Output is 6. But suppose we just swap these 7 and 4. Let's run this. So what is happening? 7 and 4. Now we are saying it is on the left side and we are checking for that condition. And it is maybe going down to a path where it doesn't exist, like the nodes doesn't exist. At that point it is exploiting exploiting it. I'll do this definitely in the tablet on paper, but I got the point. So suppose we can swap these, right? So if if let's say p val is greater than q val, p dash val is greater than q dash val, then swap p comma q. I hope this will work, right? Run. And I can add the test case of 2, 1, and this will work. I'll check out other solutions as well. And 2 and 1, right? 2 and 1. I believe there's some test, like base cases are remaining, I think. Needs to be solved. What can be the base cases? It will appear. Just oh, no base cases are there. Let me directly go through the solution then. What kind of solution? 3 line, order of 1 space, 1 line alternative. Alright. This is Java, Python, whatever. Let's check it out in Java. What? While root.val is greater than 0, root equals, what is this? Not looking at this one. C++ recursive iterative. All right. If root value is greater than p value and root value is one case is this, right, and the other case is this. if q value is greater. If both of them are greater, if both of them are less, if one is great and one is less, returning root. If both are equal, then returning root. This solution looks better actually. Other one is iterative, similar concept. All right, got the point. I believe mine solution worked, right? Otherwise, I guess it is taking too much time, or what? It is not taking too much time. This one is fine. Will take only. Let's see. I'm like removing half the tree each time, as per the dependency. And if you say, if we want to use this logic, right? If p is greater and q is also greater, suppose if such case arise, test case, p is greater and q is also greater, that means 7 and 9, right? If both of them are greater, then we are going to right side. And yeah, like this is other solution. Mine is other solution. I don't think so. Like this is better than mine solution. You know, I just missed this one, and I knew like I will have to do this. So yeah, it is going right side, and on right side it is taking. Now it is at 8. Now it can check. It will not fit in this one. It will not fit in this one. This will be returning root. This function will pop. It will be having this root value, and it will return that value and will get the answer. Yeah, this question I can also add in that recursive test. DFS question and DFS flood fill. And last one is this. What is the name? LCA tree. Okay, these three I have to do. Iterative I also like. Nice one. Let's mark it as complete then. And we are left with how many questions? This is already 43 minutes. Can't believe it. Too much time. Oh my god. Next question is balanced binary tree. Let's